Hey everybody, welcome to topic 28. In this video, I'm going to show you how to estimate population proportion. All right, so this is very similar to what we did in the previous estimation of the mean as well. So when a sample taken is a simple random sample, the condition for a binomial distribution are met, and the sample size is large enough to ensure that n times p hat is greater than or equal to 5, and n times q hat, which is 1 minus p, is greater than 5. The margin error of a confidence interval for a population proportion is given by. So this is what's different about your estimating population mean with the sigma known or sigma unknown. Is really the margin error part right here. And of course, the point estimate. So the margin error is z sub alpha over 2 times the square root of p hat times q hat divided by n. Okay, so this part is a little bit different compared to when we did um, estimate the population mean. All right, so this is population proportion p. So it's very so a lot of this stuff is basically we seeing some of the similar formulas when we talk about the central limit theorem with the proportion. All right, so number one, make sure we verify n times p hat is greater than or equal to 5 and n times q hat is greater than or equal to 5. Of course, you're gonna find the point estimate. The true population p is gonna be your best point estimate is your p hat. Find a critical value, z is alpha over 2. So this is not using t values. It's going back to using the z, the critical value z, so alpha over 2. All right, so your lower bound and your upper bound is using p hat plus or minus your margin of error. Okay, so let's try some of this example real quick. So remember, population proportion, I'm saying, it's about percentage. So we're going to turn this percentage into the decimal. So for our population proportion. All right, so let's say for this example, the State Education Commission wants to estimate the fraction of 10th grade students that have reading skill at or below the 8th grade level. Suppose a sample of 991 10th graders are drawn. Of the students are sampled, 823 read above the 8th grade level. Okay, so this is talking about at or below. There are 823 read above the 8th grade level. So to construct a 99% confidence interval for the population proportion 10th grader reading at or below. So this question is about at or below the 8th grade level. All right, so list a sample size. Okay, sample size, we draw 991 samples, right? Of the students sampled, of the 991, 823 read above. So the students, the number of individual in the sample that have the same, that have a certain characteristic, that's referring to what the question is asking, the number of students read at or below. So the X, right? The X will be the students, the people with the same characteristic. So that will be for at or below. So that will be 991 minus 823. Because this question is about, it's about estimating the proportion of the student read at or below. So if I subtract the student that read above 8th grade level, I should get 168. All right, confidence level, your C level is going to be 0.99, alpha 0.01, right? 1 minus 0.09. So alpha over 2, area of 2 tails, is going to be 0.01 divided by 2, which is 0.005. So this is the area of each tail. So, all right, your point estimate p hat is going to be the students that read at or below 168 out of the total 991. Okay, that's how we find the p hat. So this is just like very similar to what we done back when we talk about the central limit theorem to find the p hat. find the critical value of Z sub alpha for the 99% confidence. So area of each tail, right? 99%, if the middle is 99% confidence interval, the tail, each tail right now, based on the alpha over 2, is 0.05, 0.005. So to find the critical value, we got to use inverse norm. Area to the left, 0.005, comma 0, comma 1. So that gave me the critical value of this this one right here on the left of the mean. So of course the answer will be negative. So for the one on the right, that would be a positive. All right, second distribute. Number 3, 0.005, comma 0, comma 1. All right, 3 decimal place, so that will be about negative 2.576. So the other critical value should be positive 2.576, right? Because both areas is the same. All right, find the correct answer number 1, 2, and 3. Write out the computation. So I'm just gonna write this out, the lower bound and the upper bound. Okay, P hat 168 over 991 minus 2.576, right? That's my critical value, times the big old square root of, okay, P hat times Q hat. So P hat is 168 over 991 times Q hat, that would be the student that read above 8th grade level. So that will be 823 over 991, right? The binomial condition is basically saying that student either read at or below, or they read above, right? Your success and failure, that kind of sense. Divided by n 991. So I'm just gonna copy this down again, except changing the minus to a plus for the upper bound. So we gotta be very careful how we key this in. This is a lot of fraction here. And you don't want to round. You do not want to round. So we're gonna put all this in the calculator at one time. All right, so the lower bound. The upper bound, let's see. Okay, so got typing carefully, okay? All right, so the first term is a fraction, so I'm putting in parentheses, 168 divided by 991. Close parenthesis, minus 2.576 times parenthesis. I'm gonna put all this big old square root in a parenthesis, okay? Square root. So all the stuff, all this fraction craziness is all underneath the square root. So when I press the square root, it open a parenthesis for me. So I need to close a parenthesis for the square root. And I also need to close a parenthesis for the entire square root thing. Okay, because I open technically I don't have to open that one. Tell you what, let's not open that one in front of the square root, because it doesn't really make a difference. Okay, so the square root give me a parenthesis, right? The numerator needs a parenthesis. The fraction itself needs a parenthesis, because we need to figure out the top before we can divide it by the bottom. Okay, so let me kind of write like this. All right, so it's kind of weird. The extra parenthesis here is from the square root, so I got a close one. So the numerator, oops. The numerator needs a parenthesis, right? And each fraction needs another set of parentheses. So this parenthesis come with the square root. So I'm gonna open one for the numerator and then open one up for the 168 divided by 991. Close a parenthesis for the 160 for the fraction, right? So the first parenthesis again come with the square root. The next open parenthesis is for the entire numerator. The next one is for the first fraction times open parenthesis for the second fraction, 823 divided by 991. Close the parenthesis for the 9 over the second fraction, and close the parenthesis for your entire numerator. Now we divide it by 991, the simple size, and close the parenthesis that started with the square roots. So round to 3 decimal place, so that will be 0.139. 0.139 is about 13.9%. So to construct the 99% confidence interval for the population proportion 10th grader reading at or below. So at or below 8th grade level is starting at 13.9. It's from 13.9 to what upper bound? I'm gonna say second entry and go back up and change this minus 2.756 to a plus. All right, 0.2 3 decimal place 0.200. So the student read at or below based on the, the true mean, the true percentage of the student read at or below 8th grade level is about 13.9% to about 20%. 0.200 is about 20%. Okay, so that's a little bit tricky to enter all those fractions in there. You don't want to evaluate each fraction and put it in. That would be too much rounding. So let me kind of mention this one more time, okay? My square root opens a parenthesis. The next parenthesis is open up for the numerator. The following one is for the fraction, right? I open one for the fraction, I close one for the fraction. Open one for the fraction, close one for the fraction. Then I close the numerators parenthesis because I want the calculator to figure out the numerator multiplying first before divided by that 991. All right, let's use a graphing calculator, okay? So for to estimate the population proportion, we're gonna use this symbol, one population proportion Z interval. Okay, so list a sample size, the number of individuals in the sample that have the certain characteristic and the confidence level. So this problem says ABI want to determine the effectiveness for their 10 most wanted list. To do so, they need to find out the fraction of people who appear on the list that are caught. Suppose a sample of 306 suspects, a criminal is drawn. Of these people, 100 were captured. All right, so we're gonna construct an 85% confidence level. So the sample size is 306. All right, people that are captured, right? Because we're trying to construct the 85% confidence interval for the population proportion of people who are caught. Okay, who are caught. So X is the people that are caught, 100 are caught. And the C level is gonna be 0.85. Okay, so the point estimate P hat is 100 criminal got caught, suspect got caught, out of 306 sampled. So that's I'm not simplifying this, I'm just gonna write like this. All right, for the correct answer, number 1, key in the necessary information. So let me take you to there. So let's go to stats, test, go down. Z interval, T interval, 2 sample Z interval, 2 sample right here, 1 proportion Z interval. And in there, you simply ask me typing X, which is 100, suspect got caught, sample 306, enter. C level 0.85, confidence level 0.85, enter, calculate. So the lower bound 0.288. Per bound. About 0.365. So the true percentage of the suspect being caught is somewhere between 28.8% to 36.5%. All right. So just real quick, kind of showing you how we can actually estimate the true population proportion based on the p hat, based on the sample proportion. All right, so this is a manufacturing. This question is about manufacturing. Car manufacturer want to know the proportion of the new car buyer who prefer foreign car over domestic. Okay, so follow the steps that I did earlier by hand. So find the p hats, find a critical value. This is a 99% confidence interval again. All right, so make sure you enter, okay, make sure you enter the computation for the lower and upper bound and then put them in the calculator and trying to tell me what the lower bound and upper bound is for number 6. That's all the question is. All right, so thank you so much for watching.